record on this computer. So I think that now you will see annoying messages that the meeting will be recorded. So hello everybody, and welcome to our next sixth session of Open Dais. So today we will talk with Suri, Vice President of Oracle, from business IoT development and blockchain applications, and we will talk about the lessons learned from enterprise IoT deployments. So Jai, please guide us today. I'll stop sharing.
All right, thank you.
See your presentation.
Perfect. Are you able to see my presentation right now?
Yes, I can see your slides. I think I'll switch off my video just to keep the bandwidth. Yes, please take the stage.
Okay, great. Good morning and good afternoon and good evening, I guess, for some folks. Thank you so much for inviting me, Arvind. I'm not an academic like you folks, so it is a privilege to be among academics and the kind of folks that spend so much time thinking about where the world is headed next. So I'm really happy to be here. I lead our product portfolio at Oracle for our IoT and blockchain applications. I have been working on IoT apps, our IoT platforms, as Ivan knows, for the last almost 8 years now, 9 years. My previous background was in software development, especially Java, just like Ivan actually. So we go back a long way. So so in application frameworks, in the Java runtime, and in embedded environment. So have a long history in working in this industry with the different kinds of consumers in this industry, different kinds of makers in this industry. So I was talking to Ivan about what we could talk today. And one of the things that came up was, I don't have I'm not doing research right now. We're really focused on what products can we build that can solve problems that exist today. Also, of course, with a very keen eye towards where is the technology headed, where are our customers headed, where is the world headed, and keeping an eye on the trends while building products that can solve today's problems but can be easily adapted to solve problems that may arise tomorrow. So we have a lot of experience, and we spend a lot of time talking to customers, understanding market research, understanding where customers' heads are today, which way are our competitors trending. So I thought I would share some of that with you in terms of lessons that we've learned. When we see where IoT deployments are today, IoT projects are today, there's always a mixed bag of results that we notice. And then we kind of distilled out some patterns on what makes an IoT project successful and what basically are what are some factors that can indicate that, no, this is not going to go in the right direction. So let's share some of that with you. And again, thank you so much for inviting me. I'm happy to answer any questions at any time during the discussion. So feel free to, just ask questions over the chat or just, over audio. All right, I need to show this. Oh, sorry, go ahead, Amin.
Yeah, just very small interruption in the beginning that I'm tracking the question and answer section. I'm tracking the chat, so you can waste any time there, and I'll deliver this to Jai. Thank you.
Yes, thank you. All right, so since some of my content is from Oracle, I'm mostly keeping it very generic. I'm not talking about any products that we built today at Oracle, but I need to show you the safe harbor statement just because some of this content has come from our conversations at Oracle. So this is basically just saying that the information I'm providing you cannot be used for any commercial purposes for buying decisions on it. But again, we're not having any such conversation today, so we're safe from that point of view. All right, so let's start by talking about some trends and what's happening in the industry and what's basically driving much of the conversation around IoT. Yes, we know with IoT, Internet of Things came really to the forefront. And if some of you have been in this space for a while, you may remember that it used to be called M2M, machine to machine. And then this term IoT really became popular. And I think a lot of credit for that goes to Cisco and to some extent to Qualcomm and IBM also, because they really started the whole messaging around IoT and sponsoring a lot of the marketing around it. And initially, it was kind of a perfect storm of hardware becoming cheap, software becoming, much more capable of running on smaller footprint hardware, communication costs going down. So all those kind of things came together where we now had the right type of software that could run on cheap hardware with lower communication costs, which means you could do much more on devices than you could do before. So that was how much of the IoT revolution started. But where we are now trending is much bigger than that. It's not just about how do I connect things anymore. It's more about digital disruptions. And what I mean by that is this study from McKinsey, it's about a few years old, but it's still very valid. Only 8% companies believe that their business model today will remain economically viable through digitalization. And what does that mean? And many of you may be familiar with digitalization, but many companies were running sort of analog, if you will, which is basically data coming in through very manual processes or processes that are siloed. And when there was a whole different division that would focus on aggregating data, which would then build dashboards that would go to the executives. So only the executives sort of had the overall vision of where the company is, how things are moving across the different departments. And that's for many years, for decades. That's how even very large companies operated. But then came the disruptors. And we've seen disruptors across pretty much every segment. Netflix disrupted media and entertainment. Uber has disrupted personal transportation over here. We have so many examples of disruptions. And much of this disruption has been enabled because of new technology that has allowed previously unavailable information to be now available to the companies to make decisions in a much more efficient manner. And part of that is data that's sitting on devices. You may have heard the statistic that less than 1% of the data that's generated by devices actually gets used by enterprises. Very little of that data gets moved into enterprise systems. So much of that data just gets dumped right where it gets generated. Some of it gets analyzed, but only for alarm generation or some other purposes. Hardly any of it gets used to drive business processes. But if the incumbents who are running these large businesses want to survive, they need to be able to act much faster. And out of those, only 8% actually believe that the way they're doing business is going to survive moving forward. And the same survey, actually, some of the other surveys also came up with the result that IoT is very strategic to that business transformation, primarily because, again, it comes to data. Visibility into your operations is becoming far more critical. I mean, what we're seeing today with supply chain, supply chain has become a dinner table conversation. This didn't happen 2 years ago. Before pandemic, supply chain was this term that few people cared about, but most people didn't ever think about it. Now, all of a sudden, everyone's talking about supply chain because you're seeing port closures, we're seeing ships getting, blocked. Like there's a long trail of ships right outside of the Los Angeles port, outside of the Houston port, outside of some other ports in the US. We saw the Suez Canal issue that happened. All of these things are now starting to come to the forefront, and we now have challenges where you can barely even if you have all the money, you can't buy a lot of things anymore because things are just not available. So visibility is becoming far more important, and visibility not just in terms of movement of goods, but right from the design to manufacturing to warehousing to transportation and to the last mile delivery. So how can I reduce the inefficiencies across the complete spectrum over here? And IoT is becoming a critical thing over there. So where are we then with this? And so this is not a big secret. People have been talking about it for a while. Many people have tried things. One of the unfortunate truths is that many of these projects fail. This is a survey. It's a little old now. It's from 2017, which is run by Cisco, but I can guarantee you the numbers haven't changed much, because much of the progress has happened in the last couple of years. People were still trying to find their way through. The large number of folks that are running IoT projects are still not doing it to the full capacity that it should be run. The numbers have improved slightly, but they are similar in the ballpark. So back in 2017, when Cisco did a survey, they found out that only 26 companies are successful with their IoT initiatives. Compare that with the overall success rate of projects in ICT companies, as it's called, like information and communication technology companies. The overall success rate for projects in ICT companies is roughly around 38%. IoT is much lower than the overall success rate in ICT companies. Why is that? Now, that's a very important question. Yes, it's somewhat of a new technology, but is it really just because it's new technology? Another statistic is 60% of projects, even the ones that get started, 60% get stalled or go over budget because the initiatives become way more complex than someone expected. So people still don't know how to plan an IoT project, to understand what kind of resources are they going to need. How do you budget for it? People are still unclear about those things. And part of the big reason for that is a capability gap. And this is where folks like you, I think, are a big factor in how we can change that. But the capability gap is a very important trend that a lot of folks, a lot of CIOs, a lot of CEOs are starting to worry about. And this comes up in many of the conversations I have with customers. And what I mean by the capability gap is the pace of technology, the pace of change in technology has been exponential. It's been so high in the last decade or so. Yes, of course, the internet changed things. But then just in the last decade, there's so many new things that have come up, more or less driven by the focus on data. So it was the internet, and the internet, as they say, it used to be the internet of websites. You have websites coming in, and then it became the internet of data, and then it's going to become the internet of value as blockchain comes in. So we moved from just moving pages around, which had no semantic meaning to them, to start to moving data around. And now, or information became the internet of information. And now it's going to become internet of value, because we're still not moving value yet. That's where blockchain is the Web 3.0 is going to come in, where we start really shifting value. But today we are at the internet of information age, where the information expansion, with so much information out there, which has also meant that there's so many new technologies out there, everything from Industry 4.0 to Internet of Things, AI, ML, RPA, chatbots, augmented reality, virtual reality. Just there's so much going on at this time, and that the technology stacks are shifting so much as well. So how does a company that's, say, making, I don't know, furniture or making food products react to these changes? How do they stay ahead when only 8% of your companies that are incumbents will be able to survive the digitalization? How do these companies continue to keep their profits going, keep their business working the way it is and growing, because the shareholders expect that, and at the same time react to the disruptors that are coming in, who are adopting all these technologies and really leapfrogging their capabilities. That is the biggest challenge that most CEOs and chief operating officers and CIOs are facing today. How do you keep up with that capability gap? And hiring is almost off the chart. I mean, try hiring a data scientist. It's extremely difficult to hire a data scientist. And especially if you're not a data science focused company, if you're not a technology, if you're not a Google or a Facebook or an Oracle, how do you hire these people? So this is becoming a big challenge right now, and also a reason why companies are unable to make a lot of progress in these projects. But there's a silver lining here. And the silver lining is that most people, most companies that have tried IoT projects, 73% to be precise, are finding extremely useful insights that are actually helping them improve business. So of the folks that are successful, they are actually reaping the benefits right away. So this is where the balance starts to shift. Yes, there is risk, but is there reward? Is there reward? Is there that pot of gold at the end of that rainbow over here? So yes, there is value in chasing that rainbow for that reason. And even more, even the folks that failed, even the folks that started projects that got stalled, 64% learned that from stalled initiatives, they want to accelerate. They didn't go and say, we're just going to give up on this. No, they actually said, we realized the mistakes we made. We actually now realize the value we could get. So we need to even accelerate our investment in this. And 61% believe that they barely begin to scratch the surface of what is possible. So that's the opportunity here. Yes, there is risk. There's lots of pitfalls, but the reward is big. And there is a lot of opportunity for technology companies, for academics, to simplify the space, to remove a lot of the risks, to enable companies to take advantage of these technologies in a relatively risk-free way. So they can now, going back to that 8% statistic, they can now compete with folks that are trying to disrupt their business by equally being a disruptor. So how do you compete against a disruptor? You become a disruptor. And a lot of these companies have the ideas, but try changing your oil while your engine is running is not easy. And that's what these guys are trying to do. So they are really trying to change things at a very breakneck pace. But that's where we come in. That's what we want to help our customers with. So with that, let me now transition to the actual stuff that I was talking about. This was a lot of background, but hopefully what I wanted to do was give you a context of why lessons learned from enterprise IoT deployments is important, because while IoT is just like any other project, any other IT project, it does have its quirks. It does have those things where you have to know a few things in order to be successful. Otherwise, you may end up making the same mistakes that those 74% of the folks who failed at their IoT initiatives perhaps made. So let's start with that. What I did was I'm structuring this as a set of questions that I usually get when I'm talking to customers, and these are my sort of red flags. When I hear these questions, I sort of know that okay, these maybe this customer has not completely thought through what they want to do, and these are my red flag questions. So the first red flag question when I get it is, where do I start? And it's a simple question, but the fact that people ask that question itself is a bit of a red flag for me. So where do you start really with an IoT project? The answer is simple. Always start with the business outcome. And as straightforward as it may seem, it's not always what we see. A lot of times what ends up happening is companies will have somebody, go try out, buy a Raspberry Pi, buy some other, embedded board, buy a few sensors, connect that, and show some lights blinking, or even some folks go further ahead. They show that they can control a servo motor or a variable speed drive using a a Raspberry Pi, and we are running a Python program, and they go, hooray, we have IoT. We are now able to control our variable frequency drive using a Raspberry Pi. So we are making progress. Now let's put this into production. That is usually a problem. Those projects fail. And why do they fail? First thing is, if you don't know how this is going to benefit your business at the end of the day, you will start facing hurdles as you start scaling that project. Yes, it works great in a prototype environment in the lab, and that you can show that you can write a program. But once you get into, how do I scale this in my factory floor? How do I ensure reliability of this? How do I ensure auditability of this? You start hitting challenges. How do I integrate this with the rest of the stuff that I have? So our guidance to folks is always start with a business outcome. And I'll give you an example of what that means, which is basically the business outcomes could be, I want to increase productivity. I want to increase revenue. And it could be as high level as that. But those are really important goals to have. Increased productivity and increased revenue are very different outcomes. They follow completely different paths in terms of the decision tree that you build towards getting to what you want to eventually implement. Your users are different in that case. The KPIs you use are different in each case. So it's very important to understand. In some scenarios, they may be same, especially in the service industry, but most of the times they're different. Whether I'm trying to increase efficiency as opposed to I'm trying to increase revenue. Digital transformation could be a goal, which is basically I want to incorporate my operational data into my enterprise applications, such as ERP or customer experience and supply chain and so on. Understanding of the KPIs that are important for your business. And then really, why IoT? I mean, what that means is, why not just a data lake, right? Where you are bringing in data. The thing about IoT is at least from my perspective, the difference between IoT and a data lake of sensor data, and we'll talk more about this later as well, but the big difference is the real-time nature of the data, streaming data versus batch data. So data at rest. So do you really need streaming data? Do you want to incur the expenses of bringing in data in real time? Are you actually going to use it? Is your business outcome, does your business outcome require you to bring in data in a continuous manner? Or do you just really need sensor data for the last 1 week or 1 month? It's a whole different approach at that point on how you design your system. So these are important things that folks have to understand at the start and think about it before they move forward. An example I'll give you is, actually, I spoke about this, but really quick. Most projects where we see that kind of fail, if you will, or get stuck, start with some of these things. Like they start with sensors, they start with conversation about protocols, for example. And we always notice that those projects need attention. We need to guide those customers when they start with those things. Whereas if a customer comes in and starts and saying, here's my business outcome, here's what I want to achieve, tell me how IoT can help me achieve this, we know that those projects are the most likely to succeed, even if the customer has no idea about IoT and know nothing about protocols and sensors or devices and the complexity involved over there. They are most likely to succeed with their IoT projects than the guys who start on the left side over here. And as an example, here's a mill that basically takes large steel rolls of steel, and then they have this very precise knives that kind of cut the steel into thin strips, and then they recoil them. So basically, if you see as the process moves from the left to the right, it starts with the large rolls of steel, which goes through the rolling machine, and then gets cut with very precise knives into small kinds of strips, and then the strips gets recoiled again into separate coils. So what are some business outcomes that this company was seeking? So business problems rather that they were trying to address. First, They were trying to address lost production time, due to misallocation of knives. So there's manual knife setups, which are very complex, and there are hundreds of different cutting tools and spacers. So how do I know that I have the right knives for the business requirement that I have? So that typically we don't think about it as IoT, but at the end of the day, it's about understanding what the machine is doing, what's being calibrated on the machine. Lost production time due to manual inline width measurements. So they have to frequently stop and keep measuring using a caliper to see that there is no deviation in the width of the coil of the strip. So can we automate that using sensors where you perhaps use some sort of a optical width measurement tool that can allow us to basically give very precise measurement so that we don't have to stop the production line. Lost production due to poor production scheduling and equipment failures. So we know that a machine is going to potentially fail, or we don't know, but it may just have an unplanned downtime, but it has been vibrating for a few days, but no one paid attention. And then suddenly it just gives away. So now we have basically a downtime, which can cost thousands, tens of thousands of dollars, or even in some cases, we've seen where a minute of downtime can cost up to $1 million, because it's not that the minute of downtime itself costs $1 million. It's that everything stops, and to bring it up again, it may take another 6 hours, and that costs $1 million. Lost quality, which leads to poor customer satisfaction, and safety also. In some cases, failures can lead to severe safety issues. So these are the business outcomes that this customer was seeking to address. This is a great framework for us to start a conversation where we say, all right, now that you've identified this, let's break it down. And some of it may seem common sense, but the reality is we don't always see this. A lot of times when you start with IoT projects, people tend to start with sensors, thinking about sensors. So what kind of sensors do I have? Or even sometimes thinking about what kind of machines do I have and how can I control those machines, or what data can I read from those machines? But a lot of times it may not be useful at all. All right, so moving on. Question number 2. Isn't IoT just about connecting devices to the cloud? And believe it or not, we still get this question a lot. And to some extent, we have to blame the term IoT itself. It's Internet of Things, which makes the things kind of like puts things at the center of the whole pie over here. But the reality is the thing is not that important. It's the data that the thing is generating much more important. Is the information that we can get from that thing is far more important. So IoT is a bit of a misnomer from that point of view, as a nice name as it is, and no one wants to change it anymore, but it does kind of create that issue that it is misrepresenting a lot of the value that it generates. So it's not just about connecting devices to the cloud, because you're not going to get much if you just connect something to the cloud. What you care about are the end-to-end solutions, and that's the lesson over there. We need to understand, why are we connecting those devices to the cloud? Are we trying to automate a workflow? For example, the steel, the coil use case that I just mentioned a few minutes ago. One of the things was to having to stop the production line to do width measurement at every frequent intervals, just so that you know that you're maintaining quality. And then someone would go and enter the quality data into some system, and then an analyst has to review the data and say, looks good, move on. Can we automate that using sensors? Can we do it such that there is a rules engine that is constantly looking at the measurement of the width, and as soon as it deviates from a certain threshold, that triggers a quality issue that an analyst can look at and then determine if we need to stop the production line to do further calibration. That's just a very simple example of where automation comes in. But there are many, many such scenarios where what's important here is the information that's coming out of those sensors and how that drives behavior within the company, within the production line, or within your logistics solution. And the other thing to think about is also digital threads. So you have two processes, and One process is like maybe two supply chain processes. One is manufacturing, and let's the other say warehousing or shipping. And there is a set of manual steps involved in the middle. The product rolls off of the factory floor, someone picks it up, puts it on a truck, and then it drives it over to the warehouse. It sits in the warehouse, and then a shipment is created, and then they ship it out to a customer. A lot of times companies lose visibility when their products are between two of these steps, because manufacturing is done by one department, the logistics is done by someone else, and there is a whole bunch of manual steps in the middle, which is all analog, if you will. And these two systems may be completely digital. So one of the great ways to simplify this is to build a digital thread between these systems so that there is continuous flow of information from manufacturing all the way to logistics and beyond. So when someone's looking at where maybe a bottleneck is, you're not looking at points in time or not looking at just different places trying to probe things around. You're actually looking at the complete flow, and you can see where the bottleneck precisely is. And that's what a digital thread is really, kind of eliminating those blind spots. Now, digital twins is a concept which is catching up a lot. And digital twins are essentially virtual representations of those machines or those assets. And not just assets, but also physical processes. So physical entities and physical processes digitalized as digital twins so that you can interact with them just like you would interact with any other software process. And that's one of the most important terms that's coming out of the IoT space, where digital twins are really taking on their own identity now. And many software companies are actually starting to build out digital twin products today. And then finally, device connectivity options as well. Like, much of this will drive what kind of connectivity options do you really need? Do you want cellular connectivity? Do you want Wi-Fi? Do you want something else? So that's all dictated by the needs of the end-to-end solution and not the other way around. So this is an example of the kinds of solutions that we deploy today. And if you see, there's quite a bit of stuff happening here, but I'll try to kind of simplify it really quick for you guys. But basically, let's start actually on the right for a change and not follow the numbers. The numbers show data flow, but I want to just show you how this thing is set up. So here's the ERP that basically will be ordering, oops, give me a second there. Ordering equipment. You have a service management system, which is responsible for scheduling field service technicians, and there's a BI system. And this architecture is, let's say, for a company that is monitoring their equipment in the field, looking for failures, and then automatically ordering spare parts and scheduling field service technicians. So even before maybe the customer realizes that there is an issue with their forklift, the company has already done a lot of groundwork in terms of setting up a field service appointment and also making sure the parts are shipped. So how does that work? Let's say we are continuously getting data from this forklift. It goes into an IoT system. We constantly analyze that IoT data to look for faults in it. Once a fault gets detected, it goes through some sort of a rule system, which the rule system says, okay, what do I need to do for this? And one thing it may determine is go create a field service work order. The field service system can then decide, do I need to act on it right away? Which means that you now need to escalate it to a customer service representative who would call up the customer and say, we just found a problem, stop using your forklift. Or it could be that they get a notification saying, we've discovered an issue. Here are some options for a field service technician to come visit you. And they just start that workflow right away. At the same time, the system may decide that there's a spare part that will have to be replaced. So let's just kick off the process to order a new spare part and just have the spare part shipped to that right away and coordinate all of this stuff so that the spare part is available by the time the field service technician reaches there. So coordinate the timing of all of these things. So which is not a trivial problem. This now becomes an extremely complicated logistics problem. Can I ensure that the spare part is available and the field technician is also available around the same time, and the right field technician is also available around the same time who can actually fix that problem and do it in a way that we can avoid downtime for this machine so that we don't suffer with customer satisfaction. So there's, once you start thinking about it and once you expand it into a solution, you start realizing how complicated it can get to really get to unplanned downtime. If you're just focusing on telling somebody in advance that your machine's going to break, that's good, but it does not solve all problems. To solve a problem, we have to make sure that we can avoid downtime for the customer before it occurs, and that involves all of these other steps. And when the technician actually reaches there, guide them through that process, and that's where augmented reality is starting to come in. Where can we guide the technician so that they make fewer mistakes? So this is an example of how end-to-end solution would potentially work. All right, next one. Do I need support for IoT protocol X? Again, I get this question a lot. Do you support MQTT? Do I need OPC UA, or do I need AMQP or something? This is again a potential red flag, because in my mind, form follows function. Protocols should not dictate what you are able to do and what you're not able to do. Protocols, there's the great thing about IoT or standards in general is that there's so many to pick from. So it's the same thing with IoT protocols. There's so many protocols. Is every protocol the best? No. Every protocol was designed with a certain set of capabilities in mind. So we don't have a silver bullet protocol at all. MQTT solves a lot of problems, but it's not a perfect protocol for everything out there. So there are lots of considerations over here. You need to look at what kinds of devices are you going to connect? Like, are they new? Are they old? Do they have sensors on them? Do they not? When the sensors, are they battery powered, or are the sensors powered using some onboard power unit? What's the cost? We need to look at the topology. Like, are these machines that or devices that we're connecting behind a firewall, multiple layers behind a firewall? Is it even possible to communicate to the internet from those devices? Are these going to be indoors, outdoors? Are they roaming? Or are they static in one place? All of these make a difference, right? Communication, how are they going to communicate? Is cellular good enough? Is it too expensive? Or is it in a very remote location where the only option is satellite? How frequently do we want messages to be sent to us? Can we afford to do satellite, because it's really expensive? And then finally, the most important thing, security. Can someone hack into these devices and use the devices for something else? We're more and more seeing cyber attacks done via IoT devices. So security is one of the most important considerations today for IoT, and protocols play a big role in security. Protocols are one of the weak links in the security chain. So what I usually recommend to customers is start with a sensor selection framework. Start with a sensor selection framework, which allows you to set up a set of requirements, the selection criteria, and then also a description of why is that criteria important? What are the priorities over there? For example, the measurement range. What's the range of measurement that I need? Like -20 centigrade to +150. But why do you need such a high 150 centigrade temperature range for the sensor? That's because this particular thing is going to be sterilized. Yes, it usually operates at just about 40 centigrade, but this is frequently going to get sterilized. So we need to support a very high temperature range for this. Other kinds of things, what kind of connectors do I need? What kind of IP rating, which becomes extremely important. So these are lots of considerations that drive what kind of sensors selection we can do, and then the protocols that are good fits for the requirements that we have at that point. All right, so moving on then, question number 4. This is again a very common question. We have a data lake of IoT data. How do I make sense out of it? And this kind of comes back to what I was saying earlier, that do you really need streaming data or do you just want a data lake of IoT data? And constructing a data lake of IoT data, or historical IoT data, to be more precise, is cheaper. You can just lots of machines can generate data and dump that data into some sort of a file, maybe a CSV file. You can just gather up all the CSV files at a daily level or a weekly level, and then pump it into a storage system, a file system, and then you can just do data mining on it. That will give you some insights for sure. The challenge is it's all going to be retroactive. So that's where it comes down to. With data, it's always garbage in and garbage out. Is that what you need to understand for whether you need, what can you do with IoT data, whether you need a data lake, or can you make sense out of IoT data? That's the first thing, is you need to be able to map the data to something meaningful. So canonical models of different kinds of machine types, for example. So you need to be able to accommodate different kinds of data formats. And how do you do that? You need domain knowledge. You need to understand the data to start with. You need to understand what that data means. So you need more than IT folks. This is where the business guys come in. Like, they can really look at data and tell you whether something makes sense or not. So you need that domain knowledge to understand the sensor data. You need to be able to simulate, because it's not always possible to get failure data. So you may have to simulate failure and test and then iterate till you get behavior that is consistent with what you can expect in a real world environment. And then finally, you need to be able to apply machine learning and AI, which are so integral to IoT, because without ML and AI, really, it's not much use, because there's just the volume of data that exists in IoT. It's impossible to make sense out of it unless you use advanced analytics techniques. So our recommendation always is basically to, let me just build this out. Take data and start creating KPIs out of it. Detect anomalies from it, because that's something you can start doing in real time. And now that you have detected anomalies and built out KPIs, this is where the fast path, right? As soon as the data comes in, do all of this stuff. Now use that data to start doing some warm amount of calculations, which is predictions. Like, let's look at the current behavior and predict what the behavior would be a day from now. And then start using that to build much more batch analytics. This is where the historical data comes in of a large amount of time. Start doing prescriptive actions. Recommend a course of action. Like, we're seeing that a prescriptive action could be a correlation between material and quality. So, or even an operator. It's like we start noticing, based on data from like the last 1,000 production runs, that the quality suffers when Bob is at the machine A, and it's even worse when Bob is using raw material type B. And so that kind of gives you extremely prescriptive recommendation that don't combine material B and Bob at machine A. That's a recipe for bad quality. Or maybe for a root cause analysis on why is the quality always worse when these three factors get combined together. And now you can start looking at, oh, I see that the reason is because Bob's not certified to use that material on machine A. So why is he even being assigned to shifts where you're doing that? So we can start now taking action on it based on just understanding these things. But today, to even get to the bottom of things like these, it's extremely difficult in a high volume production environment. And then you can also start forecasting, like now you say, I want to, the Christmas season's coming up and we need to ramp up production. How much can we ramp up production? How much are we operating at? What's our current efficiency? Start simulating, like if I run the machine now at 90% capacity, how quickly am I going to fail? Or what will my yield be at that time? So we can start leveraging that data to do far more better, accurate business analysis. Today, a lot of this is done using mathematical models that very specialized people can do. But we can start doing this using much more real world information. And that's how you make sense out of the IoT data. All right, we're starting this is my last lesson in terms of what we've learned. How much will this cost? And this is really the most important question for a lot of folks. Sure, all the stuff you're talking about, end-to-end solutions and data lakes and machine learning, all sounds great, but how much is this going to cost me? How big is this project going to be in terms of effort, resources, money? Well, let's start. The most important lesson there is model your ROI. People tend to not do this, mostly because they get confused on how to model the ROI. And modeling the ROI for IoT projects is no different. And if the reason people struggle with modeling the ROI, by the way, I mean return on investment. Modeling return on investment for IoT projects goes back to lesson number 1. If you start with devices as your base, like which devices am I going to connect? What kinds of protocols am I going to use? If you make all those mistakes that I spoke about earlier, you won't be able to model the ROI because you have so many different factors that you just don't know how that translates into return. But if you start with the business outcome, it's extremely simple to model the ROI, even if, despite things such as IoT is always a multi-vendor solution. So you're going to have to bring in multiple vendors, such as a communication vendor, a sensor vendor, an integrator, of course, a software vendor. You have to put together a much complicated solution. And then that's where the ROI becomes extremely difficult to compute. But if you start with the business outcome and you say, well, my business outcome here is I'm going to increase efficiency by 12%. What does 12% mean for me? Well, 12% efficiency means savings of roughly $3 million a year. That's a number right away for you. So let's look at, if you're going to get to save $3 million a year, let's work backwards from there. If my solution is going to cost $2 million to operate every year because I do so many things, is it worth it? Maybe not at that point. But if I can spend just about a couple of $100,000 a year and my returns are $3 million, I have 10x ROI over here, which is amazing, more than 10x ROI over here. So that basically is where you can start measuring how much you should spend on. And a lot of folks do struggle with this because, again, they don't start with the right fundamentals, which is start with the business outcome. But it's very important to understand who is going to benefit from it. That's the, again, big piece. A lot of times the people who are making the decisions on buying something or not are not always the users. So they may not understand the benefit very well. So you have to clearly map the benefit to the end user. Can we actually measure the ROI is the important thing. So as we go along, is this just a theoretical exercise, or can we actually create KPIs that will allow us to measure the ROI once we deploy this? And then can you keep iterating on it? And that's the other important thing. As we go along, can we keep changing this? So this is an example of what the ROI might look like. Again, we spoke about the knife setup, where they saw that increasing production through elimination of inaccurate knife setups will save them this much, and so on. And just by doing these things, even if they do the first two things, they can see that they're going to save more, almost $600,000 every year. So that gives them a number to work on. And is that going to allow me, is that going to justify the investment needed for starting an IoT project? And this is how we encourage our customers to think about it. All right, so kind of summary. IoT is ready for the enterprise. I mean, as much as people think that call it still emerging technology, hopefully you folks are not in that bucket. But there are still many people out there who think IoT is something new or emerging, but it's not. It's no longer just a buzzword. It is the real thing. You can actually create measurable return on investment today with IoT, and many people are doing that. And it's not just about machines and connecting machines. It's actually benefits the entire enterprise all the way up to the CEO. everyone should care about how can I get more data from my machines, data that is currently just being thrown away. Every byte of data that a company throws away is basically leaving a tremendous value out of their information network. And very likely their customers already, their competition is already working on it. So if someone is not doing it today, they're just going to find themselves a couple of years from now that they are at a significant disadvantage because all their competition has already incorporated IoT in their environment. So our guidance to customers is absolutely move forward full speed, but don't forget the fundamentals. There are some pitfalls. Keep in mind those pitfalls. So I'm going to stop here. Ivan, hopefully that was useful. I didn't see any questions come up, but we have like a few minutes left. I'm happy to take any questions if there are any.
Yes, so first of all, thank you so much for your presentation. It's really very interesting. And I would say that possibly the things which you were discussing, you're talking about them in a perspective of IoT, but it's also can be applicable to a wide range of different projects. And you touched areas like the machine learning, so working with the data lakes and so on. So what's going far beyond what people used to call IoT, because IoT looks like it became, like you say, it's not just a buzzword, it's a part of the very big infrastructure, and it's already taken part there, and it will be there for a long time. So so I see some comment here. I don't know. Do you see the comments in the question answer section?
I do see. Yeah.
So, yeah, there is there is another invitation to be a keynote speaker at the conference. So, which actually it's a pretty strong conference actually held in our university. So that's interesting. Potentially just whenever you may have time. So yeah, that's up to. I don't
if you can connect me to Alexander through. That would be great. We can have an offline email conversation on it.
Yeah, I can introduce you both to each other, so I'll send that message to this. So yeah, it's really very interesting, and actually all areas right now are already affected by IoT. I don't know, is there anything left what is not, because the healthcare, I don't know, all emergency services, so logistics, production, IT monitoring, so just everything already covered with one way or another with IoT and with the connected devices.
Yeah, but actually, let me ask if since I don't have any questions, we have 2 minutes left here. So, did anyone disagree with any of these things? Though, I'll just clarify that a lot of this is opinion. Of course, a lot of it is common sense too. But I don't want to be presumptuous and say that everyone should agree with what I was talking about here. There could be areas where people may just disagree. So feel free to speak or comment if you think that you disagree with something in terms of prioritization, or you think that there's something else that is far more important that I did not address. But I'll just leave that. Feel free to send it as a email or something. I would love to hear from folks, because especially I don't get to talk to folks with your background as much as I talk to folks in the industry. So you may have a much different perspective to things, and I would love to hear that too. Yeah.
So yeah, if someone wants to get in touch, offline with Ajay, I think you can try contact me, and I'll just forward and redirect your questions and the comments. I think that will be very useful for both of you. And okay, so I think that's our time slot has come to an end. I know that you have a very tight schedule, and thanks a lot, Jai, for finding a time for us and coming to our stage today. That was great and interesting presentation.
Thank you.
Okay, thank you so much. Yeah, thank you so much. Bye.